Is it lighter? Most definitely. So like the advanced SolidWorks calculations I did show that it's 5 times heavier to use aluminum, which is like a lot when it adds up, right? Like if you have like hundreds, some robots have hundreds of spacers on their robot. It adds up and it can save a lot of weight over time. And is it less resources? Yes, always, because you don't need to set up the lathe. Like I'm sure you guys probably know how annoying it is to like set machines up and stuff. So clicking print's a lot easier. So I have another scenario example. Most of you guys probably know 1678 Citrus Circuits. They had a ramp this year, and they also got a Markforged this year, or 2 of them, I think. And so they utilized their Markforged a lot. That's like the expensive printer that prints. And so one scenario example I have from their robot is the ramp lock. So if you guys don't know, they had like a ramp on the side of their robot that came out at the end of the match. And then this ramp lock basically stops it from falling over during the middle of the match. So about like, let's say 2 or 3 years ago, when they didn't have a Markforged printer that could print like very structural components, they'd have to use, especially for this part, you can't really see because it's small on the screen, but it's a really complicated part. So they'd probably have to use like a 5-axis mill and have like a mentor do crazy funky stuff on like trying to make that, and it'd be really annoying and take a lot of hours. Instead, they just press print, and that's why it's so amazing. So, is it faster? Yes. You don't have to cam anything. I don't know if you guys have ever cammed a part for like a CNC or anything, but it's kind of frustrating and annoying. It can take a lot of time. And you don't have to tram a mill. You don't have to set any fixtures up. You don't have to do anything like that. It just works. Is it cheaper? Yes, always. Stock aluminum's expensive. Even with this is like they use onyx filament for carbon fiber, so the Markforged filament's like kind of expensive. It's like $200 a roll compared to like 20 for like the cheap ones, but it's still cheaper. It's like $10 versus $30 or $40 for like a big billet of aluminum. And is it lighter? Yes, of course, especially with infill. If you guys like kind of know how 3D printing works, like the basics, it's not like a solid part always. It's kind of there's like a. Can I draw on this? Yeah.
There's a whiteboard. No, like yeah, like no, like this. And then you can press. You have to press one of those buttons. Yeah.
The presentation slides are linked. What is the link? I'll write it on the board. But yeah, they can just look at it on their phones if they have it.
Brian has a laptop.
Yeah. Wait, how do I make this?
Brian, you look so confused.
What are you trying to do?
I just wanted to draw something.
There's also a whiteboard marker right here.
Yeah, can I draw? Is it like whiteboardable?
Yeah.
Okay. Anyways, I'll just continue. So yeah, like a 3D printed part is not always solid, and that's like kind of the beauty of it. It can be very strong without being heavy. And less resources, obviously, again, yes. You don't have to. That's very frustrating. So use cases for each printer. So every printer kind of has its own benefits and like what it can do. So for these like low to mid tier printers, which essentially like most teams have nowadays, most teams will have either a cheap printer or a Prusa. A lot of teams have Prusas, like they're really good and stuff. So these are like the use cases that you can have them for. So my personal, I don't know why it shows up like this, but my personal favorite is spacers. So I don't know if you can see, but I kind of pointed to them. We print every spacer. We don't buy like the acetal. You guys know what like acetal spacers are? Like the black ones you buy from Vex. They're like this long. You gotta cut them on the lathe, and it takes time, and it's really annoying. We don't do that anymore since like 2 years ago. We just like print these, and it saves a lot of time for us. And you can print a lot of spares, and it's super cheap. And then you can color code them, and then you can see which subsystem they go to super easily, and put them in bags, and it's very amazing. This is what we do now. Sensor mounts. So actually. If you want to pass this like box around, I don't know. Just like look at it. Those are all the spares that we bring to competition. So like, that's all the extra stuff we have in case something broke. So, yeah. So a lot of those are sensor mounts. You're like with 3D printing, you can design a lot of funky stuff that just fits your design, without having to waste a lot of time, kind of trying to figure out how to mount it with like an L bracket, like how you would with aluminum and stuff like that. And it allows you to put sensors in places that are more optimal. So for example, this year we used a lot of proximity sensors for our elevator to like kind of determine if it's at a height limit or at bottoming limit. And we were able to put this 3D printed mount just at the very top, and that allowed us to like put it kind of like fine tune where we wanted it to be, rather than it being fixed to where the 2x1 would be. Sensor mounts continued, so we actually we used a ton. So I use them a lot for encoders because you just need to put like 1 or 2 mounting points and then put it straight into the shaft. So it's really easy. I also put one at the bottom of the elevator, and then you can kind of like change the angle really easily, since it's like 3D printing allows for kind of weird shapes. It doesn't need to be kind of like 2.5D like a CNC would be. Pulleys. So I don't know how many of you guys have used the Vex pulleys, but they're really bad. Like the flanges break off. Does everyone like know how the flanges break off and stuff like that? It's really frustrating. So like we're kind of 1360 is gonna probably move away from buying these pulleys. We're just gonna print them. So what we do is, can I draw on the board? Okay, so you know how the pulleys kind of look like this. So you have like the you have the flanges, and then you have like the inside. This is where like the belt goes with like the teeth. And then these break off here. Like this stuff breaks off, and then your belt falls off, and that's like the worst. So I don't know how to erase. What we do? Why I already erased it? Okay. What we do is we just print the inside. We just print the inside part, and then you make these parts here, like the flanges, out of polycarbonate, and then they never break off, and it's amazing. And the best part is, with 3D printing, let me go to the next slide. I don't know how many of you guys know who Marcus Bernstein is. He's from 1836. He made a generator, and you can print any amount of teeth that you want. So you can choose your own ratios instead of having to pick what Vex Pro gives you from their website. So that's like really useful. And going back to this is a part from Celtex this year. They used compound pulleys on their intake. So instead of using like a versaplanetary like we did, which was kind of heavy, and it failed a lot because it got hit and smacked, they used belts and then just used compound pulleys, 3D printed, and it allowed them to have a really compact system, and have extras and spares, but you can't buy this from Vex. So that's like a really big pro of 3D printing, is you can make stuff that you just can't buy and allow it, and be pretty simple. They just catted it with like the 2 pulleys together and then just printed it. It was super easy. Prototyping. So this is a big one for like higher resource teams that have multiple printers usually, because like prototyping early with one printer might take a while. So I don't have Wi-Fi. I really wanted to show you guys. 125 has they have lots of printers, I think they have a Markforged or 2. And in 2017, I don't know how many of you guys know their robot. They had like the big spinning arm, and it shot balls like the fastest ever. So the way they were able to do that is in the first like couple days, they 3D printed a smaller version that used I think golf balls, and they were able to just like 3D print an entire mechanism to test that idea out super quickly, and that allowed them to prove their concept like straight off the bat in week 1, and then that allowed them to have like a really good robot. These pictures are from 2018. This is their elevator carriage bearing block. So they actually 3D printed the entire bearing block. And I don't know how many of you guys saw them at Champs, but literally like 70% of their elevator was 3D printed with a Markforged. And they were just constantly printing extra parts for their elevator, and it was really cool. They were always like, and they were even iterating. Like, it's really amazing how quickly they were able to upgrade their elevator because so much of it is 3D printed. I can't show the video. I was going to talk about our gear mechanism. I had some videos. So we, like, after our first competition in 2017, 1360, we wanted to have a ground gear. So, like, this is an upgrade a lot of teams had in that year. So we had, like, a standard mechanism, and it was kind of, like, bad. Like, had to go from the feeder station and stuff. It was kind of annoying. So we wanted to build a... Oh man. Oh, uh-oh. Oh, man. So we had a regular gear mechanism. We wanted to make it a ground gear. So we 3D printed like the plates for it, a bunch of different ones to see like which geometry was the best. And we were able to come to basically just super quickly, like each day, it was on March break, I remember. Every day we would just come home with a new 3D, or come to the shop with a new 3D print and just test new geometry. And then that allowed us to go super quickly without having to go to like our, I think at the time we had a water jet, and like that's even pretty fast, but it's still not as fast as 3D printing. And we wouldn't have to waste aluminum stock. We could just keep testing it. And then once we found the geometry we needed, we just made it out of metal, and then we were done. It was a super quick 1 week thing, and it worked perfectly. It really helped our robot. So this is like kind of pushing the limits of the mid-tier printers. So here, I'll show this part. So this part is like this thing. So this held on a pancake cylinder in this slot here, and then it connected to our climber hook. And so this piece, like, I didn't think it was gonna work, but it ended up working really well. And it didn't break because it had a lot of stress on it from like the hook. So the hook would actually push on that pancake cylinder shaft, which is like a big no-no, but it still worked. So this actually worked perfectly because in 3D printing you can add like lofts and fillets and geometry that allows you to have like strong, like, I don't know how to explain it, but it allows you to like make geometry that's like super strong. Like have you guys ever seen yeah, like honeycombs and stuff, like, you know, strong stuff. Like, I don't know how to explain it. But yeah, like you can make funky shapes and then they work really well instead of having like a bunch of plates, because to achieve where this is on this piece here, you'd have to use, in like metal, using plates, you'd have to use a bunch of different, I don't know, bolts and like standard pieces, which would take a lot more effort than it is to just put it where you want it and then have geometry to place it there. And then like another success is Team 3187. They 3D printed like everything, like their entire everything. I don't know, is anyone from 2702 in here? No? I know they 3D print, they're here today. They're Rebels. They 3D print like most of their robot too. It's really cool. But this is a team from US who 3D prints like all their joints and everything, and they make it, and they use not even a high quality printer, so it's actually really cool. And it shows like really the power of 3D printing is able to have on your robot if you don't have a lot of resources. Shooter hoods. So I don't know. Is anyone 1305 here? Damn. Okay.
2017.
Huh?
188, 2017.
Do you have pictures? No. So I stole some pictures of 1305 shooter from 2017. They 3D printed their entire hood system. Yeah, you guys can't really see, but like on a shooter, you have to have, there's like the hole for the ball, and then you have to have some way to turn it to have it to be a turret. So like in past years when teams didn't have 3D printers, they would either CNC like a gear here, or they could do like other complicated things, like you'd have to CAD a whole gear, tooth profile to be able to CNC this, or some crazy stuff like that that's really annoying. Instead, they just probably used like Marcus's pulley generator, cut out the middle, and then printed it, and that's their charting system. So that's how easy it is for them to do that. They 3D printed their entire side plate, their entire hood, everything. And it allows you to print extras, spares, and adjust the geometry super easily, like especially with a turret and a shooter. You need to be able to kind of fine-tune your angles, and it's harder to do that when you have to make an entire system out of metal, whereas you can just 3D print this one piece and then iterate it super quickly. And then an example of failure. So this year, we printed our pulleys for our cabling on our elevator, and that was really bad because it broke a lot. So we ended up just making that out of metal. So there's like cases where it's not a good idea to 3D print stuff, and I don't wanna like tell you guys that 3D printing is always the best, because it's not always the best, but it's usually the best. So now high tier 3D printers. This is the exciting stuff that like 254, 1678, 33 are pushing the limits of, and it's really, really fascinating. So that's a Markforged. If you guys haven't seen, go on Chief Delphi and look at pictures of teams using Markforged. It's really interesting. That's a U-print, so like sponsored teams will usually have this. Lots of like big companies use these because they're just like super high quality versions of kind of like a Prusa, but they can print nylon. So these print like special materials usually. So high stress grippers. I use 971 as an example. Again, I don't have the video. But their gripper this year, I don't know if you guys know, like they had like the arm. You guys know the arm looked like this. I was like, woo. They had a lot of 3D printing on that arm because it was a very complicated system with cabling and pulleys. So here you can see they use 5-axis CNC machining to get those joints, just because they didn't want to risk 3D printing it, and that's a good call on them. But in their gripper here, They used an entirely 3D printed with a Markforged carbon fiber to basically get some geometry that allowed them to have like a really compact gripping system. This gripper is actually super tiny. It's like that big, and that allowed them to grab the cubes and have a really small. Like the robot was tiny this year, like absolutely small, like tiny. They used a lot of 3D printing to be able to get this kind of minimal shape. And then I think this is my last slide. Oh no, I have one. 33 swerve. So I don't know if you guys know this here, but 33 had like the double reverse 4-bar swerve, like crazy funky robot, and they were really good this year as well. And their like base part of their swerve was 3D printed. So like you guys probably heard Carly talking about how the drivetrain is the most important part of everything you do in your robot. They risk their drivetrain, like their core part of their drivetrain, with a 3D print, and that's also another Markforged print. And then that allowed them to have like this is a super compact swerve module. I don't know if you guys have seen like other ones, but this is really nice, and they were able to achieve that form by using 3D printing on the very base because they could incorporate the bevel gear, the wheel, like the wheelbase, and just every part of it into that core 3D print. And that's just like really fascinating that they were able to use 3D printing in a case scenario like as important as a drivetrain. And a really important thing this year was bearing blocks. So I know a lot of people use like the Vex plates and stuff like that. It was very heavy and used a lot of, I don't know, time. If you didn't buy them, we had to cut them because they were out of stock. So we had to cut them and it took a lot of time on routers and stuff. This is from 2383 Ninjaneers. They just 3D printed the entire bearing block. They don't care. So they just printed out of Markforged, and they got the two side ones, the two ones going in the other direction, and they're done. That's it. This took them probably like, I don't know, not too much time to design, 30 minutes to print, and their elevator's good and ready to go. And that's all I have. So, I don't know what's wrong with that. Yes.
Why is your print such bad quality?
Mine?
Yeah. All the ones in the box.
He said, so Shadab asked, why are my prints such bad quality? Because I have the low to mid tier 3D printer.
Oh, okay.
Yeah.
You can also set the individual layer thickness.
Yeah. Oh, I guess we can talk about layer thickness. So like, I printed the highest layer height. So when you 3D print stuff, can I do this? Can I do? No.
Just turn off the. Yo, bro.
Yeah, can I turn off the board?
Yeah.
Just turn off the projector.
Wait, it's set for the finger right now.
Oh my gosh, guys, look.
No. Press it
Yeah,
again.
press yeah.
Chloe.
Yo, Brian.
Okay. Okay. Where's the? So when you 3D print stuff, there's like how high each layer is. So you can either have like a thin line, and that'll take forever. You can have like a thicker line for each layer, and that'll take a little bit less forever. And then you can have like kind of tall lines. So every time it goes up, the step is higher. So that basically takes like a fraction of the amount of time, but with lower quality. But you don't really like in FRC. Like I don't care what high quality this is. I just want it to work. And then often these higher layer heights will have stronger bonds because there's more. I don't know the math, but this is better. I heard. I did like some guy in Chief Delphi said so. But yeah, just use higher layer heights where you don't need super high quality. So like spacers. So this is like our intake spacer. So like to print it at that layer height, it'll take forever. But if you print it like that, it's already done. So that's kind of like the concept. You don't need this to be high quality. You just need it to work. So yeah. So I don't have any other questions.
It's like I had some personal anecdote. I'm a mentor with 8x4, but in the Stronghold competition, we actually printed those wheelbarrow tires. We printed 3D hubs, 3D printed the hubs for that, and we tested, put the tire on, and the first time we drove over, bumped, cracked, and broke apart. What we actually did is, if you look at how the materials on each layer 3D print, that's a stress point, that's a fracture point where that layer can separate. So if you keep parts in compression, then the parts are a lot harder, more like wear resistant. So what we actually did is we put two aluminum plates and put bolts through it, and actually held the 3D part in compression. I was able to create an airtight seal for the tire. So something just to keep in mind when you do design the 3D part is think about where the forces are applied on the part, and make sure that you're not going to be applying the force to separate the two layers. So if you're designing a spacer, for example, and you're going to be bending it, you want to be able to print the spacer maybe horizontal, so you're not going to snap the part in half.
Yeah. That's actually
Something to keep in mind when you orientate the part on the printer bed in the
Right, right, right.
If you could do it horizontally, then it would have pushed. It would have been on the flat section. Would have been stronger.
Yeah, that's actually a really good point to really talk about. So I kind of showed how this is printed this way. If I were to print it like this way, so let's say this was like that way, and then on the robot the layers are this way, and it kind of looks like that. When I put compression on it with the two plates, it might split apart kind of like a log. So like you know how like logs, like the grain goes this way, and then like it splits apart like that when you hit it with an axe. So it's like that might happen to this if you print it the wrong way. So that's why you want to print it with the layers going this way. That when you squish it, like you were saying in the back, it adds strength instead of trying to just break the.
One of the best things to do is print it and then just try to break it. And see
Yeah.
if it broke in the way that you expected, that's fine. Or print it another and just test which one. Because a part like that would take 5-10 minutes to print. So if you print two in two different orientations and see which one's the stronger, you'll get a good like understanding of how those parts break, and you'll have a better appreciation to feedback in your design.
Yeah, exactly.